In this tutorial, we're looking at 2023 paper 2 question 7, and it's mostly about trigonometry. In the first part of this question, we're given a right angle triangle. We know the hypotenuse is 70 meters and we know the perpendicular height is 9 meters. We're asked to work out the ratio of BC over AC. So obviously the first thing we have to do is find the distance AC. If you have two sides in a right angle triangle and you're trying to find the third side, you simply use Pythagoras theorem. If we use Pythagoras theorem here, we work out that AC is equal to 69.419 meters. And from there then it's easy, we just need to get BC over AC, which is 9 over 69.419, and to get it as a percentage you multiply by 100. And to the nearest percent, our answer here is 13. Okay, in part B, we're told that Olga wants to measure the vertical height of a hill. And the very top of the hill is H, and 2 points on the ground are the point O and the point P, which are 20 meters apart. We're told that directly below the top of the hill is the point O. In other words, we are given a 90-degree angle. So we have a right angle triangle, or OH, and a non-right angle triangle, or PO. And we're asked to work out the vertical height of the hill, or in other words, we need to find the distance from O to H. Now you should recognize that we have far more information about the non-right angle triangle, and we're going to use that. The first thing we're going to do is we're going to use the non-right angle triangle to find the distance from O to OR, because then I have more information about the right angle triangle and we'll be able to get OH. You should recognize that in the triangle ORP we've been given two angles, so obviously we can get the third. If this is 88 and this is 87, you get 180 degrees, you subtract 88 and you subtract 87, and it tells you that this angle is 5 degrees. So now I have an angle and I know the length of the opposite side, which means I'm going to use the sine rule. So I'm going to refer to the distance from O to OR as y, and let's try and find y. Remember, the sine rule tells me that a side over the sine of the opposite angle is equal to any other side over the sine of its opposite angle. So the side I'm going to start off with is 20, and the sine of the opposite angle is the sine of 5. So I'm using the sine rule because I know a side and its opposite angle. And the piece of information I'm trying to find is y. So that's the side is y, and the opposite angle is 87. So I'm going to write that as y over the sine of 87. So one side over the sine of the opposite angle equals any other side over the sine of its opposite angle. And obviously here we've got one equation and one unknown, so we can find a value for y. So what I'm going to do next is multiply both sides by sine 87. If you multiply the right hand side by sine 87, you just get y. If you multiply the left hand side by sine 87, you get 20 sine 87 divided by the sine of 5. And now all I have to do is plug this into my calculator and work out a value for y. And if you plug that into your calculator, in this case y works out as 229.16 meters. So now, in other words, we've worked out another piece of information about the right angle triangle. So for the rest of this question, I don't actually care about this triangle anymore. The only one I'm concerned with is the right angle triangle. We've worked out that this distance here is 229.16. So now I have enough information to work out OH. Remember that when you're dealing with right angle triangles, you should just worry about what you learned in junior cert trigonometry. This is a junior cert trigonometry question. I know the angle 17, I want to find the opposite, and I know the adjacent. So if I'm looking for the opposite and I have the adjacent, we're going to use the tan. I know that the tan of an angle is equal to the opposite, which in this case we'll call OH, divided by the adjacent. And the adjacent in this case is 229.16. So in order to get OH on its own, we just multiply both sides by 229.16. If I multiply the right by 229.16, I just get OH. And on the left, we get 229.16 times the tan of 17. And now if we just plug this into our calculator, we'll get the final answer for the vertical height of this hill. So if you plug that into your calculator, 229.16 by tan 17, your final answer is 70 meters. In part C of this question now we're moving on to trig graphs. So remember, we've studied this in section 3 in trigonometry. We're given this formula V of t, it's a cost graph, and it describes the volume of water in Olga's lungs during a test. And we're asked to work out the maximum volume and the minimum volume. Well, you should remember It's relatively easy to do this. We just need to look at the number 2 and the number 0.4. Remember that the 2 represents the midline. In other words, we can say that the average volume of air in Olga's lungs is 2 liters for the whole thing. 0.4 then is the amplitude. So the maximum, we just take the average and we add the amplitude. So the maximum, B in this case, is equal to 2.4. And to get the minimum, you just subtract 0.4. 2 minus 0.4 gives me 1.6. So your answer is that B is 2.4 and that A is 1.6. And just to be safe there, we can add in liters. We can say it's 2.4 liters and 1.6 liters. In part D, we're asked to come up with the connection between the first derivative and whether Olga is breathing in or breathing out. Well, you should remember that the first derivative always represents the rate of change of the function. And in this context, if the function itself represents the amount of air in Olga's lungs, then the rate at which it's changing refers to whether the amount of air is increasing or the amount of air is decreasing. So there are the two scenarios we have to describe. If the first derivative is greater than 0, that means that the rate of change of air in Olga's lungs is increasing. If the air in Olga's lungs is increasing, obviously she's breathing in. If the first derivative is negative, then that means the rate of change of air is decreasing. So that means that she's breathing out. In part D, we're asked to describe the relationship between the first derivative and whether Olga is breathing in or breathing out. Remember that the first derivative represents the slope of the function. In other words, the rate of change of the function. In this context, it represents the rate of change of the volume of air in Olga's lungs. So if the rate of change, if the first derivative is greater than 0, that means the volume of air in Olga's lungs is increasing, which obviously means she's breathing in. And then the opposite is true as well. If the rate of change is negative, if it's less than 0, she must be breathing out because the volume of air in her lungs is decreasing. In E part I, we're asked to work out the volume of air in Olga's lungs half a second after t equals 0. In other words, when t is equal to a half. I think the only thing you have to be careful about here is to make sure your calculator is in radians. When the angle is in terms of pi, you always need to have your calculator in terms of radians. So in this case, you change your calculator into radians and you simply sub in the formula, except instead of a t, you put in a half. And if you plug that into your calculator, your answer is 1.717 litres. In E part 2, we're asked to find the rate at which the volume of air in Olga's lungs is increasing after half a second. In other words, find the first derivative and sub in t equals a half. So let's discuss how we get the derivative of this one. The derivative of 2 is simply 0. And then the coefficient, obviously the thing we actually have to differentiate is the cos. The coefficient in front of the cos is a minus 0.4. Remember from all the differentiation we did, if you have a coefficient, you just take it down. There's nothing to be done with it, you just take it down. Then you go to your maths tables, and there's a rule that tells us how to differentiate cos x. The derivative of cos x is minus sine x. So if you have cos of something, it becomes minus sine of that thing. So cos pi over 2 times t simply becomes minus sine pi over 2 times t. But you can't forget there's one other thing we have to do. We have to now multiply by the derivative of the angle. So we have to multiply by the derivative of pi over 2 times t. What would happen if you just differentiated pi over 2 times t? Well, think about it. If you differentiate 3x, you get 3. If you differentiate 10x, you get 10. If you differentiate pi over 2 times t, t is like our x in this scenario, so you just end up with the coefficient. You simply end up with pi over 2. So we could tidy this up a little bit if we wanted to before we plug into our calculator. So obviously we have a minus by a minus, which means we're going to have a plus. 0.4 by pi over 2 is 0.4 pi over 2. And then my sign is going, my negative is gone, so this is just sine pi over 2 times t. Now all we have to do is sub in t equals a half, plug it into our calculator and get our final answer. So when you plug this into your calculator now, your final answer works out as 0.444 litres per second. Notice since V of t was in litres, now the derivative of that is in litres per second. In the final part of this question, we're told that Olga is also tested when she's exercising. Obviously when she's exercising, she's going to have more air in her lungs and she's going to be breathing more rapidly. We're told that the maximum amount of air in her lungs is 3.6 litres and the minimum amount of air is 1.3 litres. We're told that she breathes in and out twice as often as she did using the formula V of t. We're asked to come up with a formula that describes the volume of air in her lungs t seconds after she has breathed out. So obviously after she breathes out, she's at the minimum. So the reason they're saying t seconds after she breathes out is telling you that your graph is going to, basically is telling you that your graph once again is going to be a negative cost graph. After she breathes out, we start our timer. Now t equals 0 and then we go on. So it's the same shape as last time. We know that the maximum amount of air in her lungs is going to be 3.6 litres. And the minimum amount of air in her lungs is going to be 1.3 litres. To work out what the midline is, we add these two numbers together and we get their average. So 3.6 plus 1.3 divided by 2. And if we plug that into our calculator, we work out that halfway between the maximum and the minimum is 2.45 litres. Now, we can already fill in a lot of information about our graph. So let's start writing out V of t. Remember that the first number here represents whatever the midline is. In this case, the average amount of air in her lungs is going to be 2.45 litres. And then remember that it's a negative graph, first of all, because it starts at the bottom. And this number relates to the amplitude. What is the difference between 2.45 and 1.3? What is the difference between 2.45 and 3.6? Well, if you do that sum in your calculator, you get 1.15. Now, I think students are likely to find it, the hardest thing is going to be to find the coefficient of t. And the formula we're going to use to figure that out, you should have learnt off, is that c is equal to 2 pi divided by the period. So if I can figure out what the period of this graph is, well then I'll easily be able to work out what c is. I'm told that in this case, she breathes in and out twice as often as when she is resting. So in order to figure out what the period is for this graph, I first want to figure out what the period is for this graph. And in order to do that, remember the formula we used previously is we know that the period is equal to 2 pi divided by c. It's essentially the same one, just depending on whether you're looking for the period or you're looking for c. So what I want to do is figure out what is the period, how often does she breathe in and out when she's resting. Clearly in this case it would be 2 pi divided by c, and the c for when she's resting is pi over 2. So it's 2 pi divided by pi over 2. And if you plug that into your calculator, you get 4. In other words, she breathes in and out every 4 seconds when she's resting. But I know that when she's exercising, she breathes in and out twice as often. So rather than having a period of 4 seconds, the period is 2 seconds. So in this scenario, the period must be 2 seconds, which means to calculate c, it's simply 2 pi divided by 2. And obviously there the 2's cancel and you're just left with pi. So the coefficient that goes in front of t is pi. And that's your final answer. E of t is 2.45 minus 1.15 cos pi t.